Good afternoon. We finally made it to reInvent this year. It really is amazing that 12 months have passed since the last reInvent. It seems like, a couple weeks ago we were here.
Yeah. Time flies when you're having fun.
I'm Laura Squire. I'm part of the AI/ML business development team here at AWS. I work with a lot of customers, helping them implement machine learning and AI solutions. But one of my favorite jokes lately to talk about myself is I've been in this space since the turn of the century. I actually started out as a mathematical econometrician right out of grad school and moved into IT soon after. So I have been really looking at and watching this market since the mid-1990s. And I'm excited to share with you today AI/ML at Amazon.com, talking about the technology as well as talking about what Amazon's learned along the way. And pass it to Chun.
Yeah, hey, I'm Chum. I have the weirdest, longest title that you see. Doesn't really make much of a sense to you. So I have a really cool job here at AWS. My job is to basically work with Amazon.com to understand what are some of the stories and insights that Amazon has about various functional or business topics that the AWS customers might be curious to learn about. So we handle topics like AI/ML or supply chain, customer service, product management, IT, basically anything that you, if you're an executive or somebody within business or technology, may say, hey, how does Amazon think about that? What are the things that they are doing? What have they learned, both in terms of success or challenges? And what can we learn from that? That's kind of the domain that I swim in. So today we are pairing up to cover this topic called AI/ML at Amazon. And we're going to be talking about how Amazon applies machine learning to basically transform its customer experiences. So I'll bring some of the functional elements to the story, and Laura's going to cover a lot of the insights about lessons learned. And if you have any questions around both the business, functional, and technical implications of what we're talking about, we can definitely answer them through the Q&A at the end of this session. And if we run out of time, we can just congregate in the hall, and just we'll be there as long as we have to answer any of your questions there. So this is AI/ML at Amazon, but it's going to be topical as well. So just a couple questions. Any of you guys following the World Cup soccer happening? Raise your hands. Great. A lot of hands going on. Great. I won't ask you who your favorite teams are. I'll do my best to bring in some sort of a soccer example in at least my portion of the discussion, so it'll be more topical as well. Let's see. Any of you have shopped online through either Black Friday or Cyber Monday? Anybody? Anybody shop on Amazon or buy stuff there? Great. So a lot of the examples that I bring would be relevant to what you just went through and what you might experience if you bought something on Cyber Monday while you're here, and hopefully the packages that they're waiting for you at your doorsteps by the time that you get home from the conference. So I try to bring both of the elements to the story. We'll begin first by just kind of sharing some background to kind of Amazon's mindset about its experiences and relationship with the customer. So Jeff Bezos does not need much of an introduction, and he writes a letter to all the shareholders, which is public, every year. So just as a side tidbit, if you have any questions or curiosity toward what the heck is Amazon thinking, how is it thinking about reflecting on what it's done in the past couple of years, and how does it project its thinking going forward, do read our shareholder letters, because it's probably the best resource both for people in the industry and for us as employees to get a glimpse as to what our leadership is thinking about the world and how we're driving Amazon. And these statements were written, frankly, about 25 years ago among one of the earliest shareholder letters. And what Jeff says is, one, we seek out to be the Earth's most customer-centric company. And that's basically our unwritten company mission, to be the world's most customer-centric company. And the second thing is actually more relevant to our shopping experiences at the bottom, which is, look, we're very proud of the fact that we can make more items available than others, hopefully oftentimes at the cheapest possible prices. But the idea of a better customer service experience that our customers get has to be way more than that. And if you're shopping very busily on Monday or Friday, you're chasing after the deals. You are just a mouse click away from taking your shopping from one store to the other. So what Jeff is saying is, look, while we're incredibly happy and proud of our loyal customers, they're also very fickle. They can just take their shopping away with a single mouse click. So the idea of being able to offer the best possible customer service when you shop at Amazon is paramount to how Amazon sees its success as your, hopefully, partner of choice. Now, just to cast a picture, anybody Prime member at Amazon? Raise a hand. So anybody just venture to just kind of share maybe why are you a Prime member? What do you enjoy the most about the Prime program? Anybody? I hear some free shipping. Quick shipping. Prime Video? No? Prime Music? Great, great. A lot of these things. So yeah, one of the things that we try to do is to bundle up as much value as you can get out of the membership that you pay Amazon. But I'm just like you. What I love about Amazon Prime program is that there's free shipping and there's really fast shipping, oftentimes 2 days or less. But one of the things I'm most amazed by is the idea that, just when you're thinking about buying a product, it basically tells you that if you purchase the product in the next 3 hours and 14 minutes, we will guarantee that we can get it to your doorsteps tomorrow before 10 p.m. And that kind of promise really sways people's buying decisions on Amazon.com. Now, that promise to say, hey, if you make a purchase within the next whatever hour window, we will then fulfill our commitment and do our best to deliver the products to you in the time that we promised, only makes sense is only meaningful for us as shoppers if only two things happen. One is that more products that you want to buy is actually covered by the promise. And the second thing is that we definitely keep your promise, because what happens if we keep breaking the promise, then you won't trust it. It will become irrelevant. So in the worst case, it's annoying. In a bad case, it's annoying. In the worst case, we break your trust and you take your business elsewhere. So being able to make and keep that promise is incredibly important for Amazon and frankly for me as a shopper. Now, when I actually step back and look at the bigger picture, what you're seeing on the screen is a very simplified version of our supply chain. And if you listen to Adam's keynote this morning, we talked a lot about Amazon's supply chain and its experiences now being reflected into some of AWS services. But that's going to be down in the future because it's a preview. But what's happening today at Amazon is that Amazon needs to be able to predict the demand for the various goods that it's going to sell to you so that it can then procure them from the right vendors at the right volume and then place them in the right locations that is optimal to where the buyers or the shoppers will actually buy the products. And understand the delivery conditions of where every single one of our packages are in order for us to be able to then make a very confident promise to you that in Dallas, if you buy this item today, right now at this moment, we can actually get it to you by 10 p.m. tonight. But perhaps if you're in a rural location, then we will promise that we can deliver it by Wednesday evening by 10 p.m. So being able to make that promise is not just based upon the understanding of where our inventory is, but also where the various goods and delivery orders are at any given time to understand all the conditions within a supply chain, both in terms of our suppliers sending their goods to our warehouses and our delivery trucks and vans and trailers and cargo planes and where exactly things are and the logistics conditions so that we can actually make that accurate delivery promise. Now, at Amazon's scale, as you can imagine, if Amazon relied on traditional business intelligence or analytical tools to do this, we simply cannot scale when you sell more than 400 million unique items and you employ hundreds of thousands of vehicles, people, and robots to move goods around our supply chain. So the ability for Amazon to be able to do something crazy innovative on top of the speed and scale is a reason why Amazon applies machine learning to many things, including things like supply chain. Now, within that supply chain, kind of the value chain steps I talked about, one of the earliest questions that Amazon sought to solve for using machine learning more than 15 years ago was to answer this question, which is, while our fulfillment centers are humongous, their size of probably about 25 soccer pitches, going back to the soccer analogy, but we have limited space in these vast warehouses. So if you're in Chicago or Dallas or in Dubai, what customers may want to buy at any given moment, right now at the end of November into December is going to look very different because we have different seasons, different customs, different buying patterns than others. So one of the key things that Amazon has to figure out is how do we make sure that the fulfillment centers as closest to our potential customers are optimized with the right set of products that customers may want to buy. Now, predicting demand for things that have very predictable usage patterns is pretty easy. You don't need machine learning to do that, even at scale. So you know that in the summer, your kids will need sunblocks, or in the winter, they need like some sort of snow boots if you live in the right climate, is very obvious. But when you sell more than 400 million unique products, many things that you sell goes way beyond the bounds of traditional patterns and understanding. So what about slow selling items with very irregular styling patterns and very few back data? What do you do to actually forecast demand for that? Or a newfangled gadget that you've never seen before. How do you know what customers may want and where do they want it? Or things that are highly seasonal, like Halloween costumes in the United States. What's going to be the big costume this year? There's a lot of variables that goes into that makes it incredibly hard to predict. Now, not only that, at Amazon's scale, we have other challenges. So for example, in the United States, we have more than 10,000 postal codes around which Amazon has to actually predict demand at every postal code level. Las Vegas alone has more than 25. So it's not just about what do people in Las Vegas want. It's within the 25 sub-zones within Las Vegas that we have to be able to predict demand for every single items that we think the customers may want in order for us to be able to optimize what we place in the fulfillment center as close to Las Vegas as possible. Now, that idea of the scale is going to be very important, but also the underlying business conditions change. So there's a lot of inflations, supply chain bottlenecks, and different things that are happening psychologically, physically. So business conditions are changing all the time, and consumers' buying trends change all the time. So it's not just about being able to scale your understanding of the customer, it's also being able to react very quickly to the changing behaviors and dynamics in order for that forecast to stay as accurate as possible as you run a global business like Amazon's. Now, this graphic is a very simplified illustration of the traditional business applications that you may have used or have coded before in order to predict demand, right? So you take a bunch of business analysts who have a good understanding of data patterns and the rules that govern your demand forecast, and you work with really smart developers to encode as much rules as possible within lines of code. Or perhaps you get sophisticated and you have rules engine, and that lets you predict demand with your business applications. Sophisticated, encodes a lot of know-hows and insights that the humans have. Now, on the left-hand side is basically how machine learning is very different. So what machine learning is trying to seek to solve for is not human understanding of data patterns, but machines' understanding of data patterns that they can actually intuit by looking at hundreds of millions of data points across different sales data and our purchase orders and customer feedbacks and logistical conditions and everything, so that it can actually then create connections between products that humans either cannot detect or detect fast enough, so that it can borrow from the statistical powers of hundreds of similar items in order to predict the demand for this single item that I have. Again, people do similar things, but people can only intuit so many patterns, and they cannot certainly call through hundreds of millions of data points themselves to come up with that intuition. But the machines can do this within matters of hours and days. And let's say that if we were to retrain the model, right after Cyber Monday, then we actually can apply the insights of Amazon sales data from Cyber Monday to optimize demand predictions for the next week. And if we can do this next week so that we can optimize demand for the first week of December and so on, we can see how Amazon can then borrow from hundreds of billions of data points that get generated on a weekly basis at Amazon to continue to optimize our understanding of the underlying business conditions and customer behaviors so that we can continue to optimize not only what we place within our fulfillment centers, but also what we actually procure from our suppliers. So that is very, very important. And the key power that machine learning unlocks for businesses like Amazon in order for it to be able to borrow from the computation powers of machine and the connections that it can infer from hundreds of millions of data points. And that's literally what Amazon has done when it first applied machine learning to solve for the problem of what do the customers want to buy in Las Vegas in the next 4 weeks in December. Was its first foray in 2007. That was when the first production models went into production, and Amazon started to use that at scale in production. And what it unlocked was, again, the ability to use all of the data that we have previously been providing to human beings to somehow intuit based on their understanding through Excel or business analytics tool. But now we're relying on computer to actually make the connections. And obviously, Amazon has been evolving this model through multiple generations over time. And the latest techniques they're using are deep learning techniques. They can actually create a connection between non-obvious patterns and behaviors and connections that previously machines were not able to do. So for example, let's say that you're standing behind the checkout line and you see me right in front of you, and I have 3 items on my basket. I have sandals, I have swimming trunks, and I have a best-selling novel from Nora Roberts, my favorite romance novelist. Now, if you're standing behind me, what do you think I'm doing? What do you think I'm preparing for when I buy these items in the middle of November in Chicago? Yeah, you might think, hey, I might be going to Hawaii for vacation in the coming weeks. That's why I'm buying these things. Now, for human beings, that is really easy to intuit. For machines, that's impossible unless somebody has explicitly said that these items are for summer vacations or tropical vacations that people want. How do you know if they go together or not? And that's a very quick illustration of these non-linear and non-obvious relationships that the machine learning techniques can actually enable the machines to then create the connections so that it can borrow from the demand forecast of the sandals and the demand forecast for swimming trunks and the demand forecast for Nora Roberts' novel. Obviously, they'll be weighted differently, but at least they have some implications in being able to enable Amazon to predict the demand for the swimming trunks as accurately as possible. That is going to be way more accurate than just using the back data for swimming trunks sales alone. And as you know, our travel and vacation patterns have changed completely through pandemic. So if you relied on the old ways of thinking about customers' travel patterns and things, we'll be more wrong than right. So being able to create these nonlinear relationships at scale to predict demand for Amazon is incredibly important, not just because we want to optimize what we order, but we want to make sure that customers within the Las Vegas area will be as delighted as possible because we can offer even more products under our same or next day delivery promises because the stuff that they think that they want to buy in the next couple of weeks are already just miles away from their doorstep in our nearest fulfillment center. So, and then it doesn't stop with that, right? Because you saw the whole supply chain picture. But being able to turn around your mouse click when you say, buy now, into a packaged order that is now loaded onto a moving vehicle that's now moving close to your home as quickly as possible is another advantage that Amazon has. So typically within a fulfillment center, your order gets turned around into a packaged and labeled box that is loaded into a van in less than 3 hours. That's pretty remarkable because basically then our delivery promise is predicated on this idea that we understand where everything's are, but already within 3 hours, the box is loaded onto a vehicle that is headed somewhere versus taking it for weeks and days and weeks to do that. So there are many very significant examples of machine learning that we use within our warehouses to speed up that time. So one of the ideas is that instead of having dedicated shelves for novels and then dedicated shelves for apparels and dedicated shelves for something else, what Amazon does is that it stores products into these movable bins that you see here. They're actually being moved by these robots, those orange things that look like your Roomba robots. They can lift those shelves and bring it to humans, and they're guided by the machine learning algorithms that basically instructs them to go to the right people who are going to pick the items and then put them into boxes. So all of that is being orchestrated, and that is not feasible unless you're able to store items on these random fashion in these moving bins. And all of that is being orchestrated by machine learning. Now, these machines are pretty remarkable because these machines can actually lift up to about 1,000 pounds and be able to move about 5 miles per hour. So it can actually circle a soccer pitch 30 times within an hour. That's how fast these things can move. So when you have a warehouse full of these robots, not the humans moving to the shelves, but robots orchestrated and moving to people, then you can understand how Amazon can turn your purchase order into packaged products as quickly as possible, and also in risk-mitigated ways, because it minimizes human errors in picking the right products to go into those boxes. So these are just a few examples from a shopping perspective of how Amazon applies machine learning at scale in different use cases to orchestrate the movement of a single product going from a producer or supplier of the product, now moving the goods into Amazon warehouses based on our demand predictions, and within our warehouses, now moving around to get to the right people, into the right boxes, so that we can fulfill our delivery promise to you. And those promises will be in matters of days and hours versus weeks. Now, there are a couple other examples that I want to share before my half is up. So as a customer, you may say, great, so Amazon applies machine learning to get stuff to me quicker. What else does it do? Any of you have children at home? Yeah, a lot of hands, some hands. Okay, great. Any of your children have peanut allergies and nut allergies? No? A couple hands there. So you probably know that, and if you're like me, any product, any food item that you buy at the grocery store, what do with the products? You look at the ingredient list and make sure that there's no nut products. But have you ever been in a situation or have heard about an instance where the manufacturer had a defect? So maybe they forgot to list the nut item in the ingredient list. That can happen. But worse yet, what happens sometimes is that the same food product, maybe it's a box of cookies from Nabisco, is actually a process in a facility that also handles other nut products, but the product itself does not have any nuts in it. Now, so ingredient list will not say nut product, but the label should say it was handled in the facility with nut products. But if you forgot that label, and if one of our kids were eating that cookies, what happens? We'll be going to urgent care quickly. Now, Amazon has a lot of safeguards and compliance rules with its suppliers to make sure that the products are going to be free from defect, so that these kind of things are going to be exceptions and norm. But when you sell more than 400 million unique products across your global marketplace, there are going to be some products that we sell that may pose an elevated safety or health risk to our customers because they have defects. And this chart is a very simplified conceptual view of the workflow that Amazon uses to basically detect an item that may have this elevated safety risk and take actions to investigate and prevent the item from being sold. So, basically, we're gonna have a mechanism that's gonna look at a bunch of customer feedback, and then other sources. Maybe there's a newspaper article or something else that said, hey, there's a recall on this item. And then somebody's going to basically tag the item in our system for somebody at our warehouses to go and physically look at an item to confirm or maybe to disprove that it has an elevated safety risk. And if it has a safety risk, then they're going to take the follow-up actions. Maybe you have to contact the manufacturer and then basically work with them to replace the products or something else, return the products. But until then, we put the item on hold and nobody can buy it. So that sounds like a very reasonable kind of a process that you can explain to anybody. But what do you think are the limitations of this process when you're doing this manually by human beings? Any thoughts on what could be potential limitations of this approach? Human error? Yeah. They may actually read and research, and they may flag an item, but it might turn out to be false positive. Maybe that one article was wrong, and maybe the products that we happen to sell did not have that defect or risk. That could be one. Another one?
Correlating isolated feedback.
That's right, correlating isolated feedback. So for example, if there's a contract facility that just made a bunch of cookies for different brands like Nabisco, Keebler Elves, and whatever, maybe that whole week, the printing system had an issue, so it did not actually print that additional label that says this product was handled in a facility that handles other nut products. to maybe 20 other products that it handles for 5 other brands. Now, we found an issue with one brand, one product, but human beings do not know or cannot intuit or make the connection to say there are other things that we might have gotten from the same facility within the same time frame that might also have that issue. Any other thoughts? There's also a question of scale. How many can you get? Because there are going to be a lot of feedbacks and things. We cannot chase after every single thing. So what ends up happening is that we have to make some sort of compromise to say, hey, do we go for the items that we think have the biggest impact or the most serious risk? Or do we go for items where we heard the most complaints about? And then if two things are equal, do we go for top-selling products or slow-selling products? So you have to make compromises when you hit these limitations. But when Amazon was able to apply machine learning at scale to this, it was actually able to then process through hundreds of millions of customer feedbacks, sales data, recall data, reports on the items condition by our suppliers and others to then create those connections to be able to then prevent these defects and proactively address them. So a couple before and after statistics for you. So before Amazon was able to apply machine learning at this problem, the team that was handling this process was only able to tag dozens of potential concerns, and 90% of them turned out to be false alarms. So basically, we're only able to catch a few products with actual defects, but 90% of the team's effort was basically wasted in chasing after things that are false alarms. When Amazon was able to then apply machine learning at this problem, first of all, it was actually able to identify thousands of products with potential elevated safety risk. 35% of the things that the machine was able to flag were actually predictive, meaning it was not only about that one cookie that we heard complaints about, it actually raised flags for the other products that Amazon thinks has an elevated safety risk, even before hearing a single customer's complaint about it. And what the model's result is that 90% of these predictive items that it has flagged has elevated safety risk did end up having an elevated safety risk. So it's not to say that we sell a lot of defective products. That's not the lesson of it. The lesson of it is that we're able to prevent hundreds of items from being sold, which basically translates into tens of thousands of potential orders. They can potentially harm children or other customers if we were not able to predict what might have an elevated safety risk and address it appropriately. So that's also a very significant use case where machine learning enables Amazon to scale 10 times, 100 times, and that benefit is translated to customer safety in shopping with Amazon. And the final example that I bring up is how Amazon optimizes packaging. So if you have been shopping with Amazon for a long time, you would have noticed that a decade ago, we used to send everything in boxes, these corrugated cardboard boxes. But more and more, hopefully, what you'll find is that a lot of our orders are being shipped in these flexible envelope mailers that are 75% lighter and take up 40% less space because they conform to the shape of the products that are inside the packaging. So we can actually place more into the airplanes or trailers and cargo vans, so we take less vehicles to move the same amount of goods around. So it's a win for everyone. It's a win for customers like you and me, because on recycle day, I don't have to throw away bins of cardboards. It's kind of a pain to break those down and try to fit it into the boxes. But also, that creates less landfill. There's less vehicles that we need, so there's going to be less emissions. And frankly, it also reduces cost for Amazon to be able to move the same amount of goods around. Now, so being able to optimize our packaging, because we cannot ship everything in these flexible envelope mailers, because some of them are going to be more fragile, and you want them the extra protection. So we have to make decisions for every single product, what goes into what type of mailers that are optimized for customer benefits. Now, similar to the food and product safety risk example, the way that Amazon used to handle had a lot of limitations. So basically, what ended up happening is people in their fulfillment center might actually go and take a look at a product and say, hey, you know what? It's a 16-ounce bottle of something. Let's say it's shampoo. Boy, it looks fragile, so that if it taps during handling, it's going to shatter and leak. So all the body care products that are 16 ounces or bigger, from now on, they all go into cardboard. So somebody made the decision And henceforth, every single item that we sell that looks and feels like this would all go to a cardboard, which completely ignores many of the use cases. Maybe in certain countries, for the same product at the same size, we might use different packaging that might be more durable or more fragile. But when you have people handling rules just manually, you're relying on human intuitions to do that versus being data-driven. Also, again, you cannot look at 400 million unique items and put in the rules for every single one. So what you do is that you only look at the top-selling items, make the decision, and cascade the decision to hundreds or thousands of other similar products by the action of one person looking at one item. So obviously, we're only able to handle a small amount of products, so a lot of the rules are sub-optimized or not optimized at all for the actual conditions or the fragility or other characteristics that we might look at a product to optimize packaging decision. So similar to the example that we had with food and product safety, when Amazon was able to apply machine learning at this problem, it was able to take all the data points from customer feedback and from our logistics providers that told us about the fragility or the robustness of the packaging of the items to optimize the packaging for what goes into a cardboard versus flexible envelope mailers. And one of the more interesting use cases is also the idea of a collectible. So for example, if you guys, do any of you guys collect like Legos? Really? I'm at a tech conference and nobody in the room collects Legos? Some of you are lying. But let's say I collect Legos. You know that when you actually buy a collectible Lego product, you want the packaging to be pristine. You definitely want that to come in the cardboard, because if you open it up and you saw a little dent in the corner of that Lego thing that you bought, what do? You get pissed off and you want a refund. So that one has to go into cardboard. But let's say that that item has 200 pieces and it's $20. And Lego makes, let's say, 100 different lines with 200 pieces at $20, but none of them are collectible except for this one little guy that any Lego collector will recognize and say, that's got to be a limited run Luke Skywalker Jedi thing. So most of the collectors would intuitively know that's a collector's item, but nothing in the product description or in the database says that it's a collector's item. So Amazon is actually able to apply machine learning and look at all the data patterns, the purchase patterns, who's buying what, the return rate, and everything else to Intuit, that the one out of dozens of different products that may have very similar characteristics needs to go into a cardboard box because it might be more precious or a collector's item than the vast majority where it comes, and most of them are toys for my children. They come and the box is a little bit busted. Who cares? My children don't, because they're going to bust it open and start making Legos. So being able to be even more granular and precise is also adding benefit to the customer. Now, the collectibles item to me is a bit of a whimsical idea, but the overall idea is that Amazon and you and the environment benefit when Amazon is able to move away from these corrugated boxes into these kind of flexible envelope mailers. And over the past 7 years, Amazon has more than doubled the percentage of the products that it ships out. So, in 2020 alone, more than half the shipments of the orders that Amazon has shipped out to its customers went out in these flexible mailers instead of the corrugated boxes. And when you ship more than 10 billion packages in a year, that's those savings in terms of the fuel, the environmental impact, and everything else just adds up in significant ways at Amazon scale when you're able to do these kind of innovations. And innovation isn't just about having bright ideas and say, oh, that's a cool idea. It's also about translating those great ideas into production models that actually generate value for the customers and the businesses. So this team can literally say, hey, you know what? What other ideas do we have to optimize packaging that protects the product and minimize environmental impact and cost? And then be able to throw that idea into production in matters of weeks, because that team has gotten incredibly good at automating a lot of tasks involved in creating models and training the models. So they can go from idea to production in matters of weeks. So that's yet another advantage that Amazon enjoys when you're able to do this not only at scale, but also at speed with which you can actually drive your machine learning development lifecycle. So the final slide that I cover, at least in my portion, is this. The idea for Amazon is that the practical application of machine learning is table stake for Amazon to achieve its mission to be the Earth's most customer-centric in the ways that it protects customers, in the ways that it delights customers, so that Amazon is a place where you trust the brand to be the best place for you to shop. And where Amazon can make an impact in terms of machine-driven innovation is not only in the things that you can see and touch. As I mentioned, the customer promise example is deep in the bowels of Amazon's supply chain that you may not see or think about every day, but it has very direct and significant implications to your experience as a customer of Amazon. And certainly things like being able to predict what you may want to watch on a Saturday night on Amazon Prime is something that's going to delight you. The fact that we can analyze images so that you don't have to describe in a novel the neckline of a dress that you saw at a wedding and something that you want to shop for, but you don't have the words to describe. Or you just heard Adam announce today about the availability of the Just Walkout technology for many of the AWS customers to be able to enable things like cashless checkout, all driven by AI and ML, are not going to be possible without the idea and the understanding that we simply cannot deliver to the customer's high bar for what they would expect from the technology companies and their retail vendors, and be able to not only meet that demand, but continue to transform their experiences and their expectations. So hopefully you're convinced that Amazon is not just a cool online retailer, but it's also a very significant and scaled innovator using AI and ML. So we're going to transition now into what has Amazon actually learned in more than 15 years of applying AI and ML in pretty much every aspect of our businesses, and what did we learn from that that we think might be instructive and helpful for you as AWS customers as you think about your organization's machine learning journey. So I'm going to hand it over to Laura.
Thank you. Chung promised me that he would get done in 30 minutes or less. I've got 22 minutes left, so we might be doing questions in the hall. But I think with this audience today, how many folks in here are doing data science work? How many are business leaders looking to be able to do data science? And any kind of top ideas about what's the hardest thing to be successful with machine learning and AI? What are the biggest obstacles for success? Accuracy of the models, okay. Some models need to be very accurate, some don't need to be nearly as accurate. Anything else? What makes it hard? Having the right data, having access to it, asking the right question, training, having the right education for people, but also sometimes you've got to do some clever things when it comes to training the model. What we actually, classic, I worked backwards here. This is a survey that was done by O'Reilly this year, 2022, of the key challenges for AI ML adoption. And we say it's always the basics. So really, the top 4 things: lack of skilled people. We don't have enough data scientists. Lack of data or data quality issues. Difficulty in finding the right business use cases. And then the last one I think is pretty interesting. Company culture doesn't yet recognize the need for AI. And so those top 4 basic reasons, we picked those top 3. Number 4 on the list I think is an interesting one. Company culture does not yet recognize the need for AI. I think there's certainly some industries that don't see value in it. There's also another problem with company culture not recognizing the value of it. Oftentimes, those organizations are sort of early in their analytics journey. They may not have data that's centralized. They may not even be getting their reports to come out well. And now we're asking them to build predictive models. So there's sort of a maturity that customers need to go to and through until they get to the point of being very comfortable with wanting to use machine learning and AI for their business practices. So I'm going to move to What our teams found are the important topics for making sure that they are successful with machine learning. The first is ML first mindset and culture. And I'm going to talk about what Amazon does there. The second is enabling the teams. How do we make teams successful in doing machine learning? What does a team look like? The third is having a powerful data platform. How many folks listened to the keynote this morning? So we just launched a new data platform, Data Zone. Actually, it's not yet launched, but it's announced. And so that's kind of a new, more powerful data platform that we're providing to our customers. The fourth one is choosing the right first project. And we'll talk a little bit more in detail on this. And the final is how do we scale? How do we scale and become more successful over time? So when it comes to machine learning at Amazon.com, our leaders are required to answer the question, how will you use machine learning in their OP1s? It's not our leaders are asked, should you use machine learning, or are you interested in doing it? Our leaders are basically told, hey, this is what we do. We use innovation, we use technology to make better decisions. And so the question that's asked is how will you use machine learning, not if you'll use machine learning. The second is we start enabling the teams to be successful. Now back many years ago, I've been asked to do machine learning modeling projects from customers where essentially I get an extract of data sent to me and they say, find me something interesting in my data or build me a prediction. And that's never successful. It isn't. Every single machine learning project really needs to be a collaboration between, and at AWS, it's product managers, data scientists, the data engineering team, architects, and so forth, research scientists. They need to collaborate. This can't be send the data scientists down to the basement to build a model and come back up when it's perfectly predictive. But I felt like that sometimes, where that's sort of expected of me. Ultimately, our goal is to provide the technical experts the domain knowledge that they need in order to successfully develop the models, and for those domain experts to clearly define the business problem that they're trying to solve in a way that the data scientists and the other technical experts can mold their data to solve that problem. Ultimately, if you look at teams at AWS and how they grow and scale, or I should say at Amazon.com, and how they grow and scale, you start oftentimes with a team that has a product manager, and they'll reach into line of business, they'll reach into enterprise level or consultants for machine learning support, for data engineering support, et cetera, et cetera. As those product managers become more proficient utilizing machine learning for particular business problems they're trying to solve, a lot of times those teams grow and scale too. Rather than that data scientist being a pooled resource that sits within the line of business or at enterprise level, that data scientist becomes attached at the hip with that product manager. And they sit in the business meetings with the leadership to define what those projects are going to be. So it's really, the technical experts and the domain experts working hand in hand, working jointly in solving business problems using data and using predictive algorithms. So, another thing that we really want to make sure we do with our customers is give our customers an assortment of capabilities to enable them to solve the problems from difficult to simple, from different levels of complexity. So, for example, we've got AI services that are very powerful to use, very simple to use. It's a simple API call. It solves a very well-defined business problem. And then we also have ML frameworks and infrastructure solutions that give data scientists and researchers vast flexibility in what they design and define. And at Amazon.com, what they've recognized is they need to tell the data scientist, pick the tool that solves your business problem. We're not going to recommend a specific solution for you. Pick the one that fits your needs. And I think that's pretty important as well. You don't want to constrain your data science team to have to use particular technology if it's not a good fit for the business problem they're trying to solve. We heard today about data zone. What we know is if you don't have data, it's awful hard to build machine learning models, right? It's kind of a requirement. It's the first thing up front. And so we recognize data is the powering agent for machine learning and AI, but we also provide the ability for our customers to leverage third-party data sources that can be valuable for their machine learning models. So we do have marketplace available where they can go out and actually search for data sources like things like weather or economic indicators, third-party sources, and even third-party algorithms as appropriate to meet their particular needs. But essentially, you've got to realize data are the logs to the campfire. Machine learning algorithms might be the fire itself, but if you don't have the logs, you can't build the fire. So, the hard problem, choosing the right first project, right? Here are the questions that our teams generally think through when they're trying to make sure that they've defined a project that will be suitable for their business. The first one is, does it solve a real and significant problem for your business? Okay? So don't pick a trivial research project just because it's kind of cool to build a model that can do that. Or something that could be potentially driven by simply business rules that doesn't require a model at all. Really be thoughtful about the projects that you're working on and making sure that they actually meet a particular business need. And they're not just kind of fun, bright, shiny objects. There's always another bright, shiny object next month that's going to get more attention. You've got to find the significant problem. The next one is, where and how does machine learning unlock new capabilities for you? So there's two sides to machine learning that I like to think about. We provide at AWS machine learning capabilities and AI services that organizations actually plug into products that they then deliver to market. And sometimes those products are simply things like doing image recognition or doing document transcription. So we can provide those kinds of services, but we also want to be thinking about how can machine learning unlock new capabilities that you might not have thought of before in the marketplace. Things like Amazon Go, right? Leveraging AI services, image recognition, and magic, but ultimately, those are services that are providing new capabilities that are unique and differentiated. Another problem that we think about is there untapped data in our organization that if we use is going to make a contributable, valuable difference? Finally, this is the one I think is funny. Can we achieve success in 6 to 10 months? Now, I tend to like to think about projects that are 3 months. I tend to think when I work with customers, when we think about working on projects, we try to have an MVP, a minimum viable product, or an MLP, a minimum lovable product, brought to them within a 3-month window. But what we're saying is, ultimately, we want to have something viable within 6 to 10 months. Let's not make it so super complex that it's something that's never used. And then the final one, is it important enough to get sustained attention? I think this one's kind of funny. I have worked with customers over the years who have built multiple iterations of different models and maybe have a model that they built for, say, forecasting that they used 5 years ago, they spent a lot of time on, and they never go back to it. And so ultimately, what we want to be doing is thinking about developing models that are going to be important to the business, are going to have long-term business impact, and it's not just a one-off, right? It's not a one and done. It's something that's going to have sustained impact over time. So this is my favorite way of thinking through a first project. And this is just a simple prioritization matrix. And ultimately, what we want to do is we want to focus on those projects that are easy and that have high value, right? No point in focusing on that super hard project that's going to have marginal value for your organization, right? I want to do things that are going to make a big difference. I also sometimes think about it from the analogy of I could build a giant spaceship that's going to have huge high value. It's going to take 2 years to iterate on, and I'm really not sure whether at the end of that if I'm going to have something deliverable. Or I could build a canoe that solves a short-term business problem that's high value, and I might have something out the door in 3 months. Sometimes we get very enamored by our spaceship when really we should be focusing on that smaller, highly viable, high-value project. And then finally, we get to scaling. I had to speed this up today. It's all right. Finally, when we get to scaling, I know this is an eye chart. It's an eye chart intentionally. When you think about a machine learning project, back in the old days, we talked about CRISP-DM. I don't know if anybody's heard of CRISP-DM, cross-industry standard process for data mining. It was 15 years ago, we used it as a methodology to go through a machine learning problem. So you started with business understanding, you moved on to data understanding, then you moved to data preparation, modeling, model evaluation, deployment, and model monitoring. So you walk through every step in that process, and really all you really have at the end of the day is a model that you evaluate and you make a determination, does it meet my business criteria or not? Once that model has been built and you evaluate it, if it's a no, sometimes the data scientists walk away and start back again, researching and trying different methods. And if it's a yes, you've only gotten to the point of, now I've got to deploy this darn thing, right? And so deployment is one of these things that you really have to think of as well, is how am I going to plug in my model to an overall process so that model is going to get used? Now, I think of deployment as batch deployment, where I'm taking a data file and I'm scoring a data file based on a model, and I'm getting a new field or a new couple of fields with a predictive value on it. I think of it sometimes as a real-time process where a customer's online and I make a real-time prediction as they're online. What's the next likely thing I should show them? Calculate the probability that they're going to buy X, Y, or Z, serve up the one with the highest value. But then the other one that we don't often think enough about is the business insight side. So this is where you take a model, and actually it's not necessarily the prediction that matters, it's how the variables impacted on an outcome. So if I'm doing something like developing a churn model, I can build a churn model that predicts the probability the customer is going to leave me in the next 60 days. Great. But wouldn't it be more valuable for me to actually gain the insights from that model to understand what are the reasons this customer's churning and how can we positively impact it? Maybe I give that customer a treatment. Maybe I do batch score that customer based on a predictive model. But additionally, what I'm pulling out of that model are business insights that now we can use to drive and change the business. And sometimes those are just as valuable, if not more valuable. So within the machine learning process, we need to accelerate all of these steps from data preparation to model deployment. But we also have to realize that only a small piece of actually implementing machine learning in an operational process and organization is that machine learning. See the little box in the middle, ML process? Around the outside, we've got configuration, data collection, machine resourcing, verification, monitoring. So when we think of trying to scale ML, we need to be thinking through how do all of these pieces in a solution interact to provide customer with the most cohesive processes possible. So they're not having to manually string together all of these different pieces, develop code for all of them, but ultimately provide that end-to-end sourcing so that this becomes an easy problem. And ultimately, what I try to think about for what we are now today talking about as ML ops or ML operations are what are the processes that need to happen to get a model operational. Now, this doesn't mean just building a single model. This means putting a model into production in either a real-time or batch process, where now I have new data that needs to be scored. That data gets automatically prepared and scored and pushed out to where it should be pushed out to. That model is monitored in real time to be refreshed as appropriate. That model is assessed to make sure that that model meets performance expectations over time. And when that model needs to be refreshed, either a data scientist goes in and develops a new model, or maybe you auto-train a model to refresh depending on the sensitivity of the industry you're working in and the type of problem you're working with. But ultimately, the goal is to have that end-to-end integrated tools and processes. And this is really where AWS has been focusing a lot of our effort over the past couple of years. You're learning this year about how we have launching new data zone to make data discoverable and available. We have artifact repositories, things like GitHub. We have ability to do things like continuously orchestrate and refresh data pipelines, support for multiple environments, and support for modeling experiments. Obviously, on the back end, once you've got the models built, you need a way to monitor those models and track them over time, and then refresh those models and orchestrate that refresh. So ultimately, the goal is to have support for that end-to-end process. So with that, I want to get to the summary. This afternoon, I hope we shared how we see at Amazon.com AI/ML as a table stake for delivering better services to our customers. We are delivering what we refer to as differentiated impact and nonlinear scaling. So this is what we're doing is something that can improve things 800 times scale, not just 2x. We build and scale ML usage through enablers. And we're learned how to make teams work more effectively together by bringing those domain experts and those technical experts together for conversations and project design. And then finally, we discussed a bit of how we can remove and identify blocks for getting users into production with ML technologies. So with that, I have 1 minute to spare. Are there any questions?